Good morning, students. In today's lecture, we will see what are the logical operations in 8051. Mainly, we are having AND operation, OR operation, XOR operation, and complement instructions. Other than this, you are having rotate instructions, rotate right, rotate left also in logical operations. So we can see a particular number and the what is the use of and or and XOR in 8051. We are having ANL, ORL, XRL operations in 8051. ANL means ANDing with first register is always A, accumulator register or CPU, and the second operand can change. So it can be a number, hash number, and it can be a direct addressing, and it can be a register where Rn is 0 to we know that 0 to 6, and there can be immediate indirect addressing, and it can be 0 or 1. P can be 0 or 1, R1, R0 or R1. The first operand is always accumulator register. And this is applicable with ORL, XRL also. ANL A comma hash n, like that ORL A comma hash n. So ANL A comma hash n, ANL A comma address, and ANL A comma R0, ANL A comma at the rate R1. Like that ORL also. ORL A comma hash n, and it can be 30H, it is addressing, and it can be at the rate R0, that is for indirect addressing. And XRL also you are having A comma at the rate R0. So first we are going to do AND operation, then OR operation, and finally XOR operation. What is the use of AND operation in the case of this instruction? And I am taking a random number 10110, and we are going to set or reset a particular value. We are using and or instruction, and in ANL we are usually used to reset a particular bit. And suppose I take this D4th bit. For resetting the D4th bit, I put 0 in the place for the number, and all other bits are given as 1. Then what will be the resulting value after the AND operation? ANL A comma hash EF. So, and finally we get the D4th bit is reset to 0, and all other bits remains the same. So take the first number, and we do an operation with the second number in which D4th bit is 0. Then finally we get all other bits remains the same except D4. D4 is reset to 0 value. So AND operation is always used to reset a particular bit without affecting all other bits in the number. So it is for resetting any bits without affecting other bits. Okay, so now let's move to the OR instructions. I am taking the same number 10110. Then I want to set the particular D3 bit. It is initially having 0 in the bit, and we want to set the bit. Then what you should do? It can be 0 or 1. In both cases we want to set it. If it is 0 or 1, then we are not bothering about the value. We want to set the D3th bit. Then what will be? All other bits will be 0 except D3. That is used to OR with the number. So ORL A comma hash 08. This is 08. Okay. Then what happens? All other bits remains the same, but irrespective of D3 value in the first number, our result output will be 1. If it is 0, 0 or 1, 1. 1 or 1 is also 1. Okay, 1 or 0, 1, 1 or 0, 1, like that it goes. And we can see that in order to set any bit, we want to OR the operation with the number in which the particular bit you have a 1, and we are XORing a particular. XOR operation is used to toggle a particular bit. Toggle means complementing the particular bit. And XOR, we know that the d5th bit we chose for complementing, it can be 0 or 1. Let it be 1, then you can easily understand it. XOR means if both the bits are same, we will get a 1. If both are same, we will get a 0. That is 1 XOR 1 is 0, 0 XOR 0 is 0. But if it is different, we will get a 1. That is 1 XOR 0 is 1. 0 XOR 1 is also 1. Then 0 XOR 0 is 0. 1 XOR 0 is 1. 1 XOR 0 1. 0 XOR 0 0. D4th is 1. 1 XOR 0 is 1. So please note, I made a mistake here. And D5th is 1 XOR 1 is 0. So D5th bit is, we can see that the first bit in the first number changed to 0. So in order to change that, what we have done, the second number we put a 1 in the D5th position. All other bits are 0. So this is said as a masking. Hash 20H is, we can see that is 2 and 0, 20H. And in the second number that we want to do a logical operation is said as a mask, in order to change the first number into a particular required output. So the second number is always termed as a mask for the first number, and in order to get a particular required output. In the first case, we want to change the D4 bit to 0, then hash EF is used as a mask for resetting. Other operations are complementing, CPL, and then clear A. Then complement A means you will get toggle all the values, all the bits in the particular number, that is the negative. Or in clearing means we are making every bit as 0. And next we have to see what is meant by this complementing and other than rotate instructions, RL and RLC, rotate left and rotate left through carry. And we can see rotate RLA and RLCA means rotate left through carry. So that's why in order to do that, we have we let A contains a particular value, then D0, D1, D2, D3, D4, D5, D6. I am giving a random number, and in the carry flag also that there is no number in this case. In RLA, what is happening? Rotating left through left only, rotating left. Then D0 will become D1, D1 will become D2, D2 will become D3, D3 will become D4, like that, rotating one bit to left. And what happens to D7? D7 is 1. Then D7 move to the D0th position. That is, this D7 1 will move to the D0th position, and it will change to 1. And this is the case with RLA, rotate left RLA. Okay, then what about the rotate left through carry? And this is also, this rotate left is equivalent to, RLA is equivalent to multiplying by 2. You can see that first number is multiplied by 2, and the second number, if it is we are doing it 2 times, then it is equivalent to multiplying by 4. And what about RLC? That is, see, let the number be RLA rotate left through left, RLC is rotate left through carry, and a single bit is, this is 04, RLA means it becomes 08, and again we are left shifting, then it becomes 10 is equivalent to 10 is in hexadecimal. This is equivalent to 16 in decimal. Then that means first number is multiply by 2 if we are left shifting a single position, and if it is left shifting 2 positions, it is equivalent to multiplying by 4. So this is the case with the rotate. Suppose D7th bit is 1, then we are doing RLCA. Then what will be the next value? We can see that the carry flag changed to 1, and what is the value in carry is moved to the D0th bit. So other than RLA, RLCA having a different in that the value in the carry flag register moved to the D0th bit position. And what about the other thing? If you are again left shifting with carry through carry, then what will be the other value? It becomes the carry 1 go to the D0th position, and all other bits shift 1 to the left. That is D0 becomes D1, D1 becomes D2, like that. And in carry move to the D0th position. That is the case with rotate left through carry. RLCA. And this case with RRA and RRC, that is rotate right accumulator as well as rotate right accumulator through carry, and this rightmost bit will move to the carry. Here let it be RRA 10 10 10 10, then rightmost bit go to carry, so D7th in the case of RRA. That means D7 bit becomes 0, and D7 becomes D6, D6 becomes D5, D5 becomes D4, like that. It moves right 1 bit. Okay. Then what about the case with the RR? So we can see that the D7th bit is again, if you are rotating, what happens again, this D0 1 will come to the D7th bit, and D7 becomes D6, that is 10 10 10 10. No carry flag affected and changed. But if we are using RRC, then what will be the value? So we are is carry. What is the value in the carry? Move to the D7th bit. D7 become D6, D6 become D5, like that. And what is in the D0th position? Move to the carry flag register. That is, it becomes 1 in this case. If you are again right shifting, and RRC, then what becomes the carry register bit move to the D7th bit, and D7 become D6, D6 becomes D5, like that. Again a single right shifting. So this is the difference between RRA, RRC and RLA and RLC logical operations in 8051. I hope you understand. There are one more instructions, and this is also similar to multiplication by 2. In the case of RLA, this is equivalent to dividing by 2 in case of RRA. Rotate right register A is equivalent to dividing by 2. And this other one more instruction is swap instructions. Swap means we are interchanging the lower nibble with the higher nibble. That means lower 4 bits is changed to higher 4 bits, and higher 4 bits changed to lower 4 bits. Let this register contains D0, D1, D2, D3, D4, D5, D6, D7, a particular number. Let the value in the bit position be 0, 1, 1, 0, 1, 1, 1, 0. And if we are applying swap, then what will be the number swap A? Then this higher will go to the lower bit position, and this lower bits in the lower bit position move to the higher bit position. Okay, we are interchanging the first 4 bits with the last 4 bit, and last 4 bits with the first 4 bits. Then our resultant output will be 1 1 1 0 0 1 1 0. What was in the earlier in the higher 4 bits move to the lower 4 bits. This is mainly used for BCD numbers and all, and this is all about our logical operations. So we have covered this AND, OR, XOR, rotate instructions, complement instructions, clear instruction, and swap instruction in the case of logical operations.